Hey everyone, in this video we will learn how to graph the parent functions that we will use throughout the transformations unit. Every question in the transformations unit is going to be based on one of these functions. Some we already know, others will be new. So for that reason, we're going to create a table of values with at least 5 points to create each graph, and then we'll also talk about the domain and range of each function. So first we have y equals 8, which is a specific case of y equals k, or y equals a constant. So think of k as just some number. I chose 8 for this particular example. We already know that this looks like a horizontal line at y equals 8, but creating a table of values, I'm going to use -2, -1, 0, 1, and 2 as the x values. The y values will always be 8. So if we plot these points, -2, 8, -1, 8, 0, 8, 1, 8, and 2, 8, I can connect these lines with a line, connect these points rather, with a line. And there we have the line y equals 8. And it's the horizontal line that we could have drawn directly from the equation. The domain of our function, well, we can plug every x value in, so that's all reals. In interval notation, we'll go -infinity to +infinity. The range, well, the only y value on the graph is 8, so we'll use our curly brackets. Let's fix that. We'll use our curly brackets because the only value in the range is 8. So there's our first category of functions, which are constant functions, which look like horizontal lines when we graph them. We could have graphed y equals -3, we could have graphed y equals 0. I chose just to graph y equals 8 here. Our next function is y equals x. So we could graph this directly from the equation, knowing that the slope is 1 and the y-intercept is 0, 0. But let's create a table of values. So we have x and y. Again, I'll choose -2, -1, 0, 1, 2. So the y values, so we'd have -2, -1, 0, 1, 2. So if we plot our points, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, we can connect our points with a line. And there we have the graph of y equals x. And I'll label it as such. The domain of our function, again, we have all reals. We can plug every x value in. So -infinity to +infinity. And the range, working from bottom to top on the graph, we also have all reals, or -infinity to infinity. So there we have our next category of functions, which are linear functions, where there's a slope and a y-intercept. Okay, so we can classify these as linear. And I can go back to that first slide. These are constant functions. Okay, next up, we have y equals x squared. Okay, so this is the category of quadratics. And we've graphed quite a few quadratic functions already. And this is the simplest one, y equals x squared. So let's create our table of values. Again, I'll stick with the -2, -1, 0, 1, and 2. Nice x values around the origin. So let's see, if we plug -2 in, -2 squared would be +4. -1 quantity squared would be +1. 0 squared is 0, 1 squared is 1, 2 squared is 4. So plotting our points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Connect our points, create our parabola. So this is y equals x squared. So we have our parabolic curve. The domain, well, moving left to right, we can plug every x value in. So all reals, negative infinity to infinity. And our range, working from bottom to top, it starts at 0 and is equal to 0, so I'll use a bracket, and it extends all the way up to infinity. So there's our next category of functions, which are all quadratic functions, all the graphs that have a parabolic curve when we draw them. Okay, so we have 3 so far: constant functions, linear functions, quadratic functions. And these are the 3 that we've worked with mainly so far in this course. Next up, we have y equals x cubed. And this we call the cubic function. So any function with an x cubed term would be categorized as a cubic. Again, let's set up our table of values. So x, y, negative 2, negative 1, 0, 1, 2 for the x value still. So negative 2 quantity cubed is negative 8. Negative 1 quantity cubed is negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So we can plot our 5 points. So negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1. And 2, 8. So we can connect. Let's fix that. We can connect our points to create our graph of y equals x cubed. And it does look sort of like a squiggly line. The domain here, well, even though it looks like those arrows are going straight up and down, they are moving left and right as we go out. So the domain will be negative infinity to infinity, all reals. And the range, if we work from bottom to top, we see those arrows extend down and up. So all reals again, negative infinity to infinity. Okay, so there's our next category. Cubic functions, all the graphs will look similar to the graph of the parent function, y equals x cubed, a domain and range, and our table of values. So this is a new one that we're adding to our set of parent functions. Next up, y equals the absolute value of x. So we have x and y in our table. We'll stick with negative 2, negative 1, 0, 1, and 2 for our x values. So the absolute value of negative 2 is positive 2. Absolute value of negative 1 is positive 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And this is our absolute value function. So if we plot our points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, and I'm going to use the line tool to help us out here. Okay, so we extend through those points, extend through those points. So the graph is that V shape. Let me get rid of that random line. Okay, so the graph of the absolute value, y equals the absolute value of x, creates that V-shaped graph. The domain is all reals, negative infinity to infinity. Our range, we're working from bottom to top. Lowest value is 0, and it equals 0. And then it extends infinitely upwards, so to infinity. Okay, so this is also a new graph that we haven't worked with before. We know how to take the absolute value of an input, but we've never seen what that graph looks like algebraically, or graphically rather. And it should make sense that every input becomes positive, so the graph would create that V shape. Right? There's 2 ways to get an output of 2. We could take the absolute value of positive 2, or we take the absolute value of negative 2. Perfect. Now let's keep adding to our list. Next up is y equals the square root of x. Okay, so we have x and we have y. Now this is the first time we have to be a little bit more careful with picking the values for our table. We want inputs that are going to give us nice outputs in the function y equals the square root of x. So to me, that tells me to pick perfect square inputs. That would be the best case. And it also tells me that I can't plug any negative values in for x, because I don't know what the output if I have the square root of -1. Right? That's a non-real answer. So we'll start at 0, because the square root of 0 is 0. Next, I'll use 1. 1's also a perfect square. Square root of 1 is 1. Next, perfect square is 4. Square root of 4 is 2. Next perfect square is 9. Square root of 9 is 3. Now, based on the axes they gave us, that's only 4 points. And the direction said 5, but for the square root function, we make an exception. And we can say just 4 points. Sometimes we will be able to fit more based on the transformation that's happening, but we haven't learned those yet. And this is the square root function, to give it a label. Okay, so we have 0, 0, 1, 1, 4, 2, 9, 3. So we connect our points, and there we have the graph of y equals the square root of x. Now, looking at the domain and range, domain work left to right. And there's no arrow here, nor should there be. Okay, so be careful. There is no arrow there on purpose. So working from left to right, we start at 0 and go to the right infinitely. So the domain is 0 to infinity. And our range, working from bottom to top, is also 0 to infinity. I know it doesn't seem like that arrow is pointing upwards because it's kind of slowing down how fast it grows, but it's going to continue to climb upwards as it moves to the right. So this is another function, the square root of x, or the square root function, that we've worked with. We've simplified square roots frequently throughout this course. Now we're getting to see what the graph of y equals the square root of x looks like. It's the first graph that we have where the domain is not all reals. So that's an important point to focus on. Right? But now we have another function added to our list of parent functions. So let's just recap so far. Constant, linear, quadratic, cubic, absolute value, and now the square root. And we have one last one to cover. And that's y equals the cube root of x. Okay, so we have x and y. So similar to how we set up the table for the square root function, for our cube root function, we want to input perfect cubes. Okay, well, from -10 to 10, what's the lowest perfect cube? Well, that's -8. And the cube root of -8 is -2. If you need some convincing there, think about what -2 cubed is. -2 times -2 times -2, which would be -8. So the cube root of -8 is -2. And then we have -1 input, or the cube root of -1 is -1. 0 is 0. 1, cube root is 1. And 8, the cube root is 2. Another helpful way to think of this, if you go back to y equals x cubed, the cubic function, we've basically taken the table and just switched the two columns. We've switched in the x and the y columns with one another. So plotting our points, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. And just to touch on that idea quickly, there's a reason that that works. It's something called an inverse function, which we're not going to cover in this course, but if you want to go outside and do some research on that, y equals x cubed and the cube root of x are inverses of one another. And that's why those columns switch with each other. So we can connect our points. So there we have y equals the cube root of x. And the domain, working from left to right, that's all real, so negative infinity to infinity. The range, again, the arrows don't look like they're going up and down, but they're going to continue as the function keeps going left and right. So the range will also be all reals, negative infinity to infinity. So that completes our parent functions. Constant function, linear function, quadratic, cubic, absolute value, square root, and cube root. The better we know these functions, the easier our transformations become. And just to give a sense of what we're doing in the transformations unit, we're going to take these graphs and we're going to stretch them. We're going to compress them, shrink them down. We're going to move them left. We're going to move them right, up, down. And sometimes we'll do a bunch at the same time. All right. The table of values will be a really important tool for us to use to help us figure out what the graphs look like after they've been transformed. So not only do we need to know what the graphs look like, we need to know their domain and range, and knowing how to set up the table of values are all going to be essential throughout this unit. So I would make sure to practice with these and do them a few times on your own from scratch so that you feel comfortable with them, and then we can transition into the transformations part of the unit. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.